that point of time, you can ask questions if you have any. So please do open the chat box where the L&D team has posted. So just change your names by clicking on the tool, setting, profile, and edit your names there. So please do that. So meanwhile, I'll just mute everyone else and start the session. Yeah. So good morning. I'm Aishwarya. I totally have 4.3 years of experience, and it's been 2 months with Latent View. Before this, I was working with Bank of America, and prior to that, I was working with Cognizant Technology Solutions. And in this 4.3 years, I've worked in almost most of the technologies of the big data. So this is a quick introduction about myself. So I'll just start presenting the demo for today. So please do let me know in the chat box if you are able to view my screen. So are you all able to see my screen? Okay, fine. Thank you so much. So I'll just start. Okay. So what we are going to discuss today is about Hive. So I'm pretty much sure everyone would have some knowledge about SQL. But what is this Hive and why is this very popular among all the developers? And what is the origin of Hive, how it came into picture? So I will be discussing this and also the architecture of Hive and query optimizations which you can do in your process. And finally, a short demo on creations of tables, partitions will be shown at the end of this session. So then and there, I'll give a pass and unmute everyone. So if you have any clarifications, you can let me know. Okay, so let's get started. So Hive is nothing but it's a data warehouse tool that is being built on top of your HDFS layer. So you know about Hadoop distributed file system. On top of that, you have your Hive system. So this Hive first came into picture because MapReduce was there, right? So MapReduce was very complex and people found it very difficult to write the queries in MapReduce as the base of MapReduce is nothing but Java. So many developers thought, okay, it's very difficult for me to understand Java and get converted into a Java person. So what they thought was they were looking for some other alternative with which they can get into this Hadoop. And one such method was Hive. So Hive is more or less similar to your SQL. So whatever you do in your SQL, the same thing you can replicate in your Hive. So Hive is nothing but a SQL on top of your Hadoop distributed file system. So earlier you only had HDFS for storage and MapReduce for processing. Then what they did, they introduced this Hive. So Hive was used for processing very large volumes of data. And one more important thing is, so this particular Hive is ANSI SQL compliant, which means whatever you do in SQL, you can do the same with some limitations in Hive. So I'll also be discussing on the limitation and some additional properties which are not there in SQL. Those things also you can do it in Hive. And Hive is basically designed only for OLAP. So what is OLAP? OLAP is nothing but online analytical processing. So like a typical RDBMS system, this Hive cannot be used for online transactional processing. Hive can only be used for online analytical processing. Means you have the data and on top of the data, you want to do analysis for a large volume of data. In that case, you can use Hive. So Hive, and one more thing is it is structured. Means you have to create a table, load the data into the table, and then only you can query on top of the data. So Hive is mostly for structured, large volumes, online analytical processing, and it has SQL dialect. So that's why people go for Hive, and this is the origin of Hive. Next, what we can do is we can go for the architecture of Hive. So how is Hive built? So whenever you're giving a SQL kind of query in Hive, internally what is happening and what is making it similar to SQL. So there are four important components in the Hive architecture. So one is your Hadoop core components. Then you have your Metastore. Third one is your driver, and finally you have the Hive client. So these are the four important core components of the Apache Hive. Okay. So what is Hadoop core component? You know, it's only two things. One is your HDFS, and another one is your MapReduce. HDFS means whenever you're going to create a table in Hive, by default, it will be stored in the Hive data warehouse location, which is nothing but user Hive warehouse. In that location, it will be stored. It will differ from system to system, which you can go and read in hivesite.xml. There is a file called as hivesite.xml. Mostly developers will not have access to it. So that is where your data resides in HDFS. So HDFS is one component. And similarly, whatever query you're going to give to Hive, internally, it gets translated into MapReduce job. So, but you'll not be able to see like how it gets converted. But when you fire any of your Hive query, you can see that it gets splitted into stages. Stages internally has map task, reduce task, and finally what will happen, your query will produce an output. So it converts your query into a Java class, and it builds a jar and executes the jar file internally. So that's what happens in case of MapReduce. Then the next most important component of Hive is your Metastore. Metastore is actually the heart of your Apache Hive Apache Hive means it is a central repository. What does that mean? Means in the Metastore, you have the metadata of the Hive store. What do I mean by metadata? It's nothing but data about data. So you create a database, you're creating tables, you have partitions, columns, data types. So there should be some central repository for managing all these things, and that is nothing but your meta store. So by default, Hive comes with a Derby SQL server. So it has a Derby SQL server, which means Hive as well as the Derby SQL server runs on the same JVM. So this Derby SQL server consists of the metadata. But for a large enterprise like Latent View and all, you cannot go with this Derby SQL option, because when you go with Hive integrated with Derby SQL, you can open only one session at a time. When multiple users want to open Hive and want to work means, in that case, this Derby SQL server will not be supported. In that case, what happens is there are some other meta stores called as the embedded metastore, local metastore, as well as the remote metastores. So in that, embedded will support only one session, local and metastore will support multiple sessions. So big enterprises will be using some other external database for storing their metadata, which is nothing but SQL. Say for example, SQL is one of the database where all your metadata can be stored. So metadata internally, there will be 51 tables. Okay, so out of which 3 tables is very important. One is your DB table and one is your TBL table. Other one is your column tables, which will explain you about the databases, who is the owner of the database, location of the database, and then what is the table present inside that database, who is the owner of that particular table, is it an internal table or external table. So I'll also be explaining the difference between these two at the end of the session. So internal table or external table. And then finally, you also have a columns table in the metadata, which will show what all columns you have and what all data types you have. So this is all about Metastore. Metastore is the most important component of your Apache Hive. Next, third one is your driver. So a driver whenever you're firing your query, internally parsing semantic analysis happens and it finally executes a logical plan on how your query must run. Say for example, I'm doing a select star from one table, join and select star from another table. Okay, so there will be three stages and let's create a DAG, like in which sequence or in which order my query has to run. So that particular logical plan is devised by the driver. So the query which you submit is translated into MapReduce with the help of the Hive packages which is already present. So that is all about driver. And finally, it is your Hive client. So what do I mean by Hive client? Is the interface through which you communicate with Hive. So there are multiple clients, Hive clients, through which you can communicate with Hive. So either through the beeline or also some of the web interfaces like Q, Ambari, you can connect with Hive. So at the end of the session, the demo will be only through Hive. So through the web interface Q, I'll be showing some quick examples of Hive. So these are some of the Hive clients, and when you connect to the Hive via a Hive client, internally it also connects to the Metastore. So these are the four important components of Apache Hive. So when you submit a query, what happens in the background? So all these components come together, play a vital role in translating your Hive query into a MapReduce job and then produces a output. So this is an overview of the Apache Hive architecture. So I'm just pausing for a minute. So I'm just unmuting everyone. So if you have. So are there any questions now, or can we proceed? Okay, so I take it as a no and I'll proceed. Okay, so moving on to the next session is the Hive query optimization. So what is Hive query optimization means? When you write a query, there are multiple things which happens in the background which makes your query to run slower, or latency will happen when you run a query. So there are a lot of mechanisms with which you can make your query run faster. There are two ways with which the optimization can be done. So one is at the client side and other is at the server side. But as of now, we will be discussing only the methods or the techniques that can be taken through the client side, because the client is the one who is responsible for writing the query and he has the whole control while giving the query. So as of now, let's get into the methods or techniques of how your query can be optimized and what are the techniques to make it run faster. So the first method is parallelism. So as the name suggests, what is parallelism and what would be the requirement of parallelism? So on the left hand side, if you see, I'm pretty much you'll not be able to see the entire code. What we are just doing is selecting few columns from one set of table and joining it with some other set of table. So I've written two subqueries and doing a join in between, which means there are three stages. So the first subquery has to run, then join, and then the final subquery has to run. So if the parallelism is not set, so by default, the parallelism will be false. So if you don't have parallelism, then what will happen is first the stage one, that is the first block of the code will run. Only after the successful completion of the first block, the second block, which is the second subquery, will run. And after the successful completion of the second block, the last stage, which is join, that will happen. So stage one, stage two, stage three, it will be it will not be dependent. Okay, so it just waits for each of the tasks to complete. even though they are independent to each other. So in order to avoid this, what we can do is we can set a parameter called as set hive.execution.parallel is equal to true. So that way you can do, say for example, set hive.execution.parallel equal to true. If you do that, what will happen in the background is Hive will go and internally understand, okay, this block stage 1 and the block stage 2, they are independent of each other. Let's run it in parallel. So stage 1 and stage 2, without waiting for each of them to complete, will run in parallel. And finally, which is the joint condition, that will run stage 3. So with this, what will happen? The time for the execution of your complete query will be less when compared to running your query without setting these parameters. So this is one optimization, and also there is one more parameter called as hive.execution.parallel.thread.number is equal to 16. What that means is, say for example, how many stages or how many threads can run in parallel. That is decided by this particular number. Okay, so by default this number is set to 8, and you can increase the numbers depending upon how huge your query is and how many independent tasks you have in your query. So with that you can come to a conclusion. So these two parameters will define your parallelism. Okay, so parallelism is one of the most important query optimization technique. Next, moving on to the next one, we are going to talk about compression. So many of us would know what compression means. Means you are going to reduce the overall size of your file by imposing some of the techniques, compression techniques. You are going to follow some of the compression techniques so that the time taken would be less. So there are three ways to achieve this compression in Hive. One is you can compress the input files, or you can compress the intermediate output files, or finally you can compress the output files. So what does this mean internally is, you are doing a select star from your table, say for example. So in that case, Hive will go and connect to HDFS and it will start reading your file. So if your file itself is compressed through some compression techniques like gzip compression or something, in that case, the time taken to read that input file itself would be very less. So at that point of time itself, we would have reduced some amount of time. And say for example, if your file is going to end with some extensions like .gz and something, so internally Hive will understand, okay, this is a .gz extension file. So let me go and read this particular file and identify it as gzip compressed file and read it with the gzip codec. So this is internally what will happen when you compress the input file. And then there is another part called as compressing intermediate output file. So what does that mean is, when you are running a query, you know, right? So it is getting translated into map job as well as a reduce job. So mappers, if there are n number of mappers, each of the mapper will produce an intermediate local file. So that particular intermediate local file also we can compress, so that when the reducer is trying to read the compressed file, the time taken to read that file will be reduced. So that is what you call as compressing the intermediate output file. So that by default would be false. You can set this parameter like set hive.execution.compress.intermediate is equal to true. So what will happen is, with this, your intermediate output files which the mapper produces would be very less. Okay, and then finally the most important thing is compressing your output file. If you want to save more of the disk space, what you can do, whatever output the Hive query is going to produce, you can also compress that. So how can you achieve that? You can do it by two things. One is hive.execution.compress.output property to true. You can set that particular property, and internally Hive will use one of the codec that is configured by the mapred.map.output.compression.codec property. So this part might be slightly confusing. What I'm trying to say is, with the help of compression, the time to read the file, to process the file, and to save the file can be considerably reduced by setting these parameters. That is what I'm trying to tell. So input side, you can do a compression, and in the intermediate output files which the mapper produces at that point of time, you can do a compression. And finally, after all the processing is done, the final output with which the files will get stored at that point of time also, you can do compression. So till now, we have seen two methods of query optimization. One was parallelism, which was straightforward. And next one is compression. So with compression, we can compress the input files, intermediate output files, and the final output file. Moving on, next topic is vectorization. So what do I mean by vectorization, and what important role does this vectorization play is, say for example, if I am going to fire a query like select star from so and so table where I put a condition. So there what happens, a full table scan will happen. So row by row, my Hive will go and scan each of the rows to find my output, which will eventually take a lot of time. So though your query is very simple and straightforward, what will happen just because of this full table scan, the time taken for your output will be very more. So in order to avoid that, we can have something called as vectorization. With vectorization, 1024 rows are processed at one time. Okay, so at a time, if you enable this vectorization, 1024 batches of 1024 rows will be processed. So the time taken to connect to the metastore and get the output will be very less, and so the output you are expecting will come in a very less time when you enable this vectorization properties. Okay, so these are the two properties which you have to set. One is your hive.vectorize.execution.enabled equal to true. Similarly for reducer also. So hive.vectorize.execution.reduce.enabled equal to true. So with the process of vectorization, the time taken to scan your entire table will be less because it processes the data in 1024 records. And whatever I'm saying, right, all this optimization techniques will be applicable only if your data volume is large. For small data, so these things will not be applicable. If I'm having a very simple table of 100 records, means all these are not required. So whatever we are discussing is at an enterprise level where you have TBs of data that gets processed. So at that point of time, I can use parallelism is one concept, compression is another concept, and vectorization is the third concept of optimization. And there are also further optimizations, but at this point of time, I'm just giving a pause. So I'll unmute everyone. So if you have any questions, you can let me know. So are there any questions? Is everything clear now?
Yeah, I have a question, Ashok.
Yeah.
For a fair amount of size that Hive usually handles, I want to have a number like this was NGB or GB, that kind of number. Just to go with the Hive, like, why are we moving with the normal RDBMS and Hive? Like, how we differ, when we should go for Hive? So that kind of clarity.
Yeah. Okay. So you are asking like when should we go for RDBMS and when should we go for Hive? I mean, at what volumes for Hive, correct?
Yeah.
So when we go for RDBMS, when we have online transactional processing and we want all the asset properties to happen. You know about asset properties, right? Atomicity, isolation, durability, and locking mechanisms. If you want all those things to happen, and online transactional processing, if you want to happen, and if you need an entity relationship kind of thing, in that case, you can go for RDBMS. But RDBMS will not be able to process such a huge volume of data. So what do I mean by huge volume is, so every day, if you are going to process some MBs of data or maybe some GBs of data, RDBMS you can still use. But when it comes to Hive, Hive is not suitable for online transactional processing. Say, for example, you go to ATM, you're going to do a swipe, you're going to come back. So all those things immediately in the backend, if you want to store, you cannot use Hive. So in those cases, you definitely have to go to RDBMS only. Okay, I am telling we can go to Hive when you have to do analysis on top of the online transactional processing data. At the end of the day, bank is coming to me and saying, okay, these many records or these many people have swiped the ATM and this is the amount. Do some analysis on top of it and give me the results back. Or if I'm going to do a batch processing kind of thing, then in that case, you can go for Hive. Hive also has some additional properties and it's also SQL compliant. That's why most of them will prefer Hive. And it's Hive not for very small amount of data. It is basically for 100 GBs or TBs of data if you are going to process on a day-to-day basis. In that case, you can go for Hive.
Yeah, that's very helpful.
Okay. Yeah, thanks. Okay, I'll unmute everyone and I'll start with the next thing. Okay. So next is the most important property or important part of the session, which is partitioning, and you also have bucketing. So what do I mean by partitioning and why does Hive has partitioning internally is? Say for example, everyone has Windows Explorer and you have movies, right? So everyone would have been seeing some movies at some point of time. So you're storing all the movies in one particular disk. And one fine day when I'm going to come and search for one movie, what will happen? I have to go through each of the movie and say, okay, where is that movie? Where is that movie? I have to do a full table scan in that part of time. So the time taken for me will be very more. So what I decide, okay, let's make subfolders like Telugu movies, Tamil movies, Hindi movies. So let's make subfolders and arrange the movies accordingly. So I have a main folder called as movies, and inside that movies I have several subfolders called as Tamil movies, English movies, Hindi and Telugu movies, and inside which I have my data residing. So if I wish to watch any of the English movies, I need not go through the rest of the 3 directories. Directly, I can go to the English movies folder and whichever film I want, I can just go and watch. So that similar concept is partitioning in Hive. So in order to avoid full table scan, so again and again, I want to avoid a full table scan. In that case, I can go for partitioning. Say for example, I have a very huge data set where the business is always interested on year of joining. So how many people have joined per year? They are always interested on that and they keep querying that particular column. And it has less distinct values. In that case, what I will do is, I will go and partition on top of year of joining. So I'll have the main data and also subdirectories. So directories will be created with year of joining. So year of joining equal to 2018, year of joining equal to 2019 and also 2020. So like this, subdirectories will be created so that when the business comes and if they are going to do a query, select star from so and so table where year of joining equal to 2020, it will directly jump into the 2020 folder and avoid the other folders so that the time taken to query and retrieve the output will be very less when you so that is the most important advantage of partitioning. Okay, and you know, right? So when I am going to do a select star from internally, it also gets converted into map reduce jobs. If I don't do partitioning on top of data, then what will happen? The time taken to retrieve the output will be very, very high. But one important thing to notice, always you cannot do partitioning. Okay, so partitioning, the most important thing is the way you choose the column to partition. So I cannot go and do partitioning on employee ID, because in my organization, if there are 3 lakh employees means, so what will happen? All those 3 lakh employees will have unique employee IDs. What will happen? So inside my main data, 3 lakh subdirectories will be created, which will again turn to be a overhead. So you should not make the process more difficult. Instead, choosing wisely the partition column is the first important step. First, you have to understand and analyze which column is being frequently used by the business. So that is point number 1. Next one is, does that column has minimum distinct values? So it should not be like all the values in the table. If I have 10 million records, all the 10 million records of that particular column should not be unique. In that case, what will happen? Again, 10 million unique directories will be created, and when I go and query that, the time taken to retrieve the result will be even more. So the overhead will be more in that case. So those are some restrictions. And also, if a table is going to be very small, for example, if I'm creating some of the temporary tables, in those cases, I need not do a partition. So partition should be done only when your data is very huge and when you are trying to retrieve the data from one particular column which is frequently being queried and it has minimum distinct values. So these are the things which you have to consider when you do partitioning. And partitioning is of 2 different types. One is your static partitioning, other one is your dynamic partitioning. So what is static? By the name, you can understand that static is constant. It's not going to change. Dynamic means changes time to time. So you can create a table and then you can add partition on its own, or let the system decide the partition. That is dynamic partition. So static partition comes into picture when you know the data. That is very important. So if I'm having 10 million records and I know, okay, totally year of joining will be only from 2000 to 2010. So when I know that very clearly, I can go ahead and do year of joining is equal to 2000, year of joining equal to 2001. Means I have to go and explicitly declare the partitions when I'm running the queries. That is static partitioning. And next one is your dynamic partitioning. Dynamic partitioning means you need not go and explicitly declare the partitions. You simply have to mention the partitioning column alone. So if I'm going to partition on year of joining, I can simply give year of joining as the partition column alone. I need not go and specify any particular value for dynamic partition. And dynamic partition will not be enabled by default. You have to set these 2 parameters for your dynamic partition to happen. Set hive.execution.dynamic.partition equal to true, and the mode should be non-strict. So in these cases only dynamic partition can be done in Hive. And mostly in the enterprise level, people will not go and explicitly declare the partitions, that is static partitioning. Instead, they will give only dynamic partitioning into picture. So dynamic partition is only most widely used than the static partitioning. So this is all about partitioning. Let me just summarize. So partitioning can be used only if your volume of data is very huge. You are going to frequently query on one particular column, and that particular column should have minimum distinct values. Because if it does not have minimum distinct values, again it will create an overhead and the throughput will be very less. Okay, So these are the conditions that has to be considered when you design a table with partitions. And if you are going to specify a column as a partitioned column, that column should not be included in the create table statement. So in the final demo, I'll quickly show those things also. So this is all about partitioning. Moving on, let's go to bucketing. Bucketing is another one mechanism of Hive. Means what we can do is, on top of partition data, if I even more want to dig the data, or if I want even more fine granularity on the data, I go for bucketing. Say for example, I have a requirement like I want partition by country, and then again I want to do some operation on the cities of each country. So in that case, what you can do, partition by country and bucketing by city. So you can use bucketing at that point of time. And inside bucketing, what happens is internally a modulo operation is happening, and you should specify like how many buckets has to be created when you write the query. Like clustered by is the keyword for bucketing. So clustered into how many buckets. So clustered by which column and into how many number of buckets, like 4 buckets or 8 buckets or 10 buckets. So what do I mean by buckets is, if I am going to cluster by city, for each of the city, a modulo operation will happen. And based on that, each of that city will fall under one bucket. If I'm having 4 buckets, so all of my cities will go through this modulo function internally, and it will get splitted across this 4 buckets and not more than that. This is bucketing. And your partitioned columns will be directories, and your bucketed columns will be stored as your hash file name. So the last line of the slide, which shows, so department is equal to administration. That is a partitioned column, which will be a directory. And inside that directory, it has a bucket hash value file name. So all the bucketed values will be stored as files. And bucketing cannot happen on its own. You have to set this particular property, which is nothing but set hive.enforce.bucketing is equal to true. So with this, you can enforce bucketing also. So you can combine partitioning as well as bucketing. If you see, this is one example. So create table name, partitioned by which all columns, clustered by which columns, sorted by which column, into how many buckets. To how many buckets you want your data to be splitted across. Based on that, internally a modulo operation will happen and will store your records. So this is all about bucketing. I'll just pause for a minute. So if you have any questions, you can ask. Are there any questions?
Yeah, when we do that partition, at the time also it will create separate folders, right? Like how it is different from bucketing?
So partitioning, how it is, partitioning will be created as subdirectories. So if you go and see your data in Hive, right? So Hive, first your database name, table name will be there. Then whatever partitioned column and the partitioned value is there. Like say for example, country is equal to India. If I'm going to integrate partitioning along with bucketing, then what will happen is, again hash value followed by the file name will be there. So internally hashing will happen and it will be stored as file names. So bucketed columns will be stored as file names, and partitioning, bucketing, there is no much difference. Both these things are just for retrieving your query output very fast. Just for that thing we are going. So mostly people prefer partitioning. So they don't go for partitioning integrated with bucketing. So they restrict themselves with dynamic partitioning and proceed. So if you want even more fine granularity, and even more if I want to query on top of the data, then only in that case they'll go for bucketing. So inside country, if I want more information on cities, means again and again repeatedly they're going to query on some cities, means then they will decide, okay, let's go for bucketing, and they will divide it into buckets and then further do that. So did I answer your question? Oh. Okay, so we'll just move on to the next topic. Okay, so next performance optimization is what we are going to discuss is joints. Okay, so everyone, everywhere, be it SQL or any place, the query will not be completed without using a join. So similar to SQL, Hive also has joins. Inner join, left outer join, right outer join, outer join. So it follows the same mechanism as of how SQL follows. There is no much difference in it. So adding to that, there are some other joins called as map join, bucketed map join, skew join, and even more, amongst which we will be discussing only three. One is the map join, bucketed map joins, and the skew join. So only these three things we will be discussing because it considerably improves your performance. Okay. What is map join? When I decide, okay, I'm going to join two tables. One table is a very big table which has a column called as country code. And another table is a very small table. So country code has codes such as AU, NZ, IN, something like that. And the table with which I'm going to join is a lookup table. It's a very small table which is in some MBs or KBs of volume alone, which will have description of the country codes. So AU means Australia, NZ is New Zealand, IN is India. So this kind of structure I'm having in a small table. Well, what I want to achieve is I want to join these two tables and form a new column called as country code description with the country codes expanded. So that is my aim. So this is one use case where I can use map join. What I'm trying to do is I'm trying to join a bigger table with a smaller table. Okay, so that smaller table, you can go for a map join. So a map join is also called as a broadcast join. So when will I decide when to go for map join? Two cases. One thing is your table should be of very small size. Not small sizes, 25 MB is the maximum limit your small table can be. I mean the table with which you join should be of small size. That is one condition. So what happens is it follows the concept of broadcasting. So you all have WhatsApp, right? So WhatsApp, you do broadcasting. If I don't want to open a group and I want to send a group message to everyone, I just open a broadcast, send message to everyone in the group. But everyone in the group will not know each other, but only the person who sends will know who all are there in the broadcast. Similar thing happens in the map side join. When I do a map side join, the small table, right, it gets cached. It gets stored in the memory, and a copy of it will be distributed to all the mappers, so that when I do the join, the mapper phase itself, the values will be retrieved without going to the reducers phase. So let me explain that with the diagram. Here, if you see small table data, so A is a very small table. I am trying to do a map side join on top of that small table. So internally, what will happen is it gets converted into hash table files and then gets into the distributed cache, and then a copy of it will be allocated to all the mappers. So this, when it joins with the big table, the time to retrieve the output will be very less. Okay, so hence in this way, all the mappers can load this hash table file into the memory and then do the join in the map state itself. So in the map state itself, you are doing the join. So how do you do that? You do that with two parameters. One is hive dot auto dot convert dot join is equal to true. And what is the other condition? Non-conditional task is when I am trying to join three tables, and amongst those three tables, two tables are going to be small, means internally what will happen if n-1 file is going to be equal to 10 MB, then it will be converted into a single map join instead of creating two separate map joins. So just to summarize, map side join you will be using only when when the table you're trying to join is going to be of very small size. It is very small, and in that case I'll be doing a map side join. When you do a map side join, what will happen internally? You will broadcast the data to all the mappers so that the join completes at the map phase itself without the need to go to the reducer phase. Okay, so map join is very important, and many people will use map side join for improving their query performance. So this is all about map side join. Moving on, let's move to the next concept called as bucketed map join. What is bucketed map join? It is similar to map join, but on one condition. Means if you're going to join two tables and two tables are bucketed on the same columns on which you are going to impose the join. Means if I am having an employee table and having a department table, okay, so employee table and department table, if it has some ID in common and I'm planning to join these two tables on top of that particular ID, and internally I have also bucketed them, okay, in that case I can go for bucketed map joins. Means A table is there, B table is there. A is bucketed on user ID into 4 buckets. Then in that case, B should also be bucketed on user ID into 4 or multiples of 4 buckets. So that is where you can go for this bucketed map join. Okay, so bucketed map join is also similar to your map join, only on one case your table should be bucketed, and the join condition, like the on clause where you put the join condition, those values should be bucketed. Okay, so this is one scenario to improve the query optimizations. Mostly people will not go for bucketed map joins because people using buckets itself is very less. So people generally go for map join, and then another join which is coming in the next phase, which is your skew joints. So skew joints is very, very important. I just want to stress on this because when we are doing a query, many people face this skew joint issue. Okay, there is some issue with the skew joint. Skewness happens when, so I'll just explain it with an example so that it will be very clear. So I have two tables. You can see the requirements on the screen. So first table has 100 million records, and it has a field called as code ID, and that code ID has values ranging from 1 to 10,000. Amongst which 99 million has the same code ID called 250, and only the remaining 1 million records has values ranging from 1 to 10,000. But dimension table, it has 10,000 records, and it is a little big enough so that I'll not be able to do a map side join, and it has a column called as code ID, which is always unique. Now if I'm trying to do a join on the code ID, skewness will happen. What do I mean by skewness is, you can see the query, select star from a table, do a left join on the other table on these conditions. When you do this, what will happen? From reducer phase 1 to 99 will run very quickly in 1 or 2 minutes, and the reducer which has that particular code ID as 250, right, it will be running for 1 hour, 2 hours, 3 hours. So and what we will be thinking, okay, it is because of some input output IO issue or Hive connectivity issues because of which this is happening. Internally, no. So internally this is happening because of the skewness of your data. So how can we avoid it? There are multiple ways of doing it. One is you can split your actual query into 2 parts. Means if your query is very small and if you are able to understand the query, you can split it into 2 parts. like do the join with code ID not equal to 250 and one more query with code ID equal to 250 and do a union all. So that in that case, the time taken to complete will be very less. But there are limitations for this also, because all these things which I am explaining is only for very small queries. If your query is very large and if you want to split it across, you have to take all the logics into consideration. And if you break any logic, then the time taken for debugging itself will be very more. So in those cases, what we can do is, there are some of the inbuilt Hive configurations that can be set without changing your query. So whatever 4 parameters which are set in the last part of the slide, right? So you can use these particular Hive optimizations so that the skewness can be considerably reduced. There is also a detailed note on what these parameters will be doing. I'll also share the link to that. If you have time, you can just go through that. Okay, so this is all what I had for today. So the time is very less. Let's just jump into the demo and then I'll just do a quick Q&A. So this is the online Hue editor, which anyone can use for doing some practice sessions on Hive. So this is where I'll be showing a quick demo. So this is the front end web interface, which I was discussing at the start of the session. So I have some inbuilt queries, which is ready. So I've already created this database. So this is the database which I have already created. Let me quickly go and just use that particular database. So the syntax will be almost similar to what you have in SQL. And this is how you create a table. I'll just drop and recreate it once. So it is nothing but create table, table name. You specify all the columns along with its data types. And these 4 parts is very important. While creating the query, right, you have to give how your row format delimited or not. Like if you're going to load the data via a file, then how is that file separated? So is it is the value separated with a tab space, or is it a pipe delimited file, or is it a comma separated file? All those things you have to specify this place here. So instead of /t, which is tab, you can replace it with comma if it is a comma separated file. You can replace it with a pipe if it is a pipe separated file. Okay, and each of the line, how is it terminated? So obviously it will be terminated with a new line, and by default I'm saying store as a text file. If you don't specify this thing, it will be specified as a text file. There are multiple formats of storing your file, like you have your ORC file, Parquet file, multiple things are there, but as of now I'm just taking the simple example of stored as text file. I'm just putting this. So table will be created. So if you see right here, so I said, right, the driver will return all these things: semantic analysis completed, and what is the time taken to execute. And I am trying to insert some values into this table. I'm doing an insert. Let me run this. See, if you see here, there is something called as job, right? So this query internally has been converted into a MapReduce job. Okay, so this, if you see, it will be divided into stages. So how much % of your map has been completed? How much % of your reducer has been completed? You can check the progress over here, or else you can also right click on it and see. like where it has progressed by using the standard output, standard error, system log files. You can check the progress of the MapReduce jobs also. See. So map is 0%, reduce is 0%, and for this job to complete, number of mappers is 1, number of reducers is 0. Because I'm not doing any aggregation or joins or anything, right? I'm simply trying to do a insert. So this is the time taken. If you see, the map is 100%, reduce 0%. So the time has completed over here. So simply if you go and do a select star from, so you see, right? So whatever I have entered, that you're able to see. And quickly, I'll also show a demo on partitions. So this is how you create a partitioned table. So if you see partitioned by clause, you have to give and what column you have to partition and its data type. You see that year of joining is not included in the create table statement. This was what I was specifying when we walked through the partition session. So whatever you specify in the partition column, right, that should not be part of your create table statement. And adding the partition. How are you adding the partition? This is a way to add the partition. Insert into table, table name, partition. Explicitly, I'm specifying year of joining equal to 2019 and the values. So this is how you have to specify. There are also multiple ways of doing it. But just to start with, I have just showed these things as example. I'll also share these things and also the link so that you all can go and check through it. And also I have a question in the chat box, like what is the use case of the bucketing or partitions? How to decide we need to use the partitions? What is the performance difference? Okay. So when do we consider partitioning and when do we consider bucketing? This is what I was explaining, right? So partitioning is when you are frequently querying on one particular column again and again. So if I'm saying I want to partition on year of joining again and again, in that case, people will go for partitioning. Bucketing, people will go if you want even more fine granularity. Hive is actually like you don't have normalized data, right? It is denormalized. You have multiple columns which is interlinked. So if you want fine granularity on your querying or the output, in that case, people go for bucketing. But mostly people restrict themselves with partitioning and not with bucketing. Mostly, I have not personally used bucketing. So I've used only partitioning. Dynamic partitioning is what I've personally used. Bucketing, I've just tried using it, but at the enterprise level, I have not bucketed any of the columns. So bucketing is just an additional feature on top of partitioning, and also you can do bucketing even without a partitioning. There are also some syntaxes for that, which I'll also share shortly. Okay, so this is the end of the session. So if you have any questions, you can just let me know. I'll unmute. Okay, so if there are no questions, we can end the session. Thank you all for joining the session. So if you have any queries in Hive, you can drop a note to me at any time. I'll try to respond as fast as possible. Thank you so much and have a good day.